Okay, good morning. It's June 29, 2023. The time is around 12:29 p.m. Okay, this is Professor David J. De Los Reyes. My discussion for tonight will be a long video format on the subject matter algebra, and I will now be on lesson number 7. It's getting interested. So our topic for this morning will be an interesting one. This should be the rules on exponents. Okay, let's proceed. Our lesson for tonight is, or for this morning will be algebra. This is a long video format, so we discuss concepts and example problems. Lesson number 7, and this is the title for this morning will be Exponential Rules Summary. So whether you are new or been studying algebra for a long time, this is the summary of exponential rules. This will not change. So if you know it, you know it. Okay, let's proceed. Number 1, the product rule. Exponential problems always come out or came out on the shorts videos because they are anticipating students to learn when they took up the CAT or the SAT exam. Okay, so for this morning, I will be discussing the concepts of exponential rules. Number 1, the product rule. The product rule. Okay. The form of the product rule is a raised to m multiplied by. I place a dot for multiplication, or I could place a small letter x. But to be more cleaner, we'll just place a dot. It is understood to be the operation to be multiplication. I will repeat it. A raised to m multiplied by a raised to n. If we try to simplify this one, the simplification will be same base a, and the exponent will be the sum of m plus n. Okay? Take note, the base are the same, right? But the exponent are different. So if we try to take the simplification of this, okay, it will be that same base, and the exponent will be the sum of the exponent. Oh, it's easy to visualize. I will give you an example. Okay? 2 raised to the third power multiplied by 2 raised to the second power, and this should be equal to, okay? The base is 2, and the exponent of the first base is actually 3, and the exponent of the next term with the same base is 2. So if we try to follow this one, okay, it will be the same base. We will write that same base, and the exponent should be the sum. It is 3 plus 2. So this is raised to 3 plus 2. If we try to take the simplification of this should be 2 raised to 3 plus 2 is actually 5. And 2 to the 5th power is actually how much? 2 to the 4th is 16. So this should be 32. Okay. Will it be correct? Let's check it without using the rule, okay? 2 cube is 8, right? 2 cube is 8. Without using this, what is 2 squared? It is 4. So actually the given problem is actually the product of 8 times 4 without using the rule. Okay? And actually if we try to divide 8 times 4, that will be equal to 32. So an illustrative example for the first product rule will be this one, 2 to the third power times 2 squared, and this should be equal to, by following this, it should be same base, and the exponent will be the sum of the exponent. We don't multiply the exponent, we add, okay? So this should be 2 raised to 3 plus 2, which is to the 5. And 2 to the 5 is actually 32. And as the validity to the check, without using this rule, we could evaluate immediately 2 cube, which is 8, and 2 square is 4, and 8 times 4 will be 32. So they are actually the same. Okay, as easy as that one, guys. So whether whether we are young or old, we will follow this one till we die. This will not change. Okay, let's proceed with the quotient rule. That's the product rule. Okay, the product rule that is under same base. Okay, the quotient rule is still under same base. This product rule is actually same base. Same base. And also this one, same base. Okay, so don't forget this one. For the quotient rule, meaning quotient, we are dividing, right? And e raised to m divided by e raised to n. And this should be equal to, if we try to simplify this one, since the bases are the same, we will just rewrite the base. And the resulting exponent will be the exponent of the numerator minus the exponent of the denominator. Okay? Why is that so? It is something like this. We could actually simplify this one to be e raised to m, right? If we try to raise this one to the denominator, it will become, the operation will become multiplication, right? If we try to raise it, it will be e raised to minus n, right? So if we try to simplify this one, we'll follow the product rule, because it's now a product instead of a quotient after transposing this one to the numerator. So it will be same base. According to the product rule, it should be the sum of the exponent, right? Raised to m plus open quantity negative n. We are to add the exponent, but be sure to put a parenthesis, because this is negative and this is plus. So this will now be equal to a raised to, a plus in a minus will be minus, so it will become a raised to m minus n. And this one here is actually this. Okay? So actually, we could derive the quotient rule by using the product rule, but we should what you call this, put the denominator first on the numerator. So when it goes up, the exponent will become negative, right? This was originally plus, right? So when we raise it up, the exponent will become negative. So after the rising up, the operation now will change from division to multiplication. So upon the transferring of the denominator to the numerator, we could invoke the rule and the product rule now to simplify this quotient rule. And that is actually a raised to the exponent m minus n. This is. Okay? We do not need to give you an example on this one. I think this is more than enough illustration how it came out as a raised to m minus n. Okay. Number 3, the zero exponent. In general, a raised to 0 power will be equal to 1 with the given condition a is not equal to 0. Because if a is equal to 0, what will come out will be a 0 raised to 0 power. Okay, and this is indeterminate. Okay, we could not evaluate that one under mathematics. That's why we term it indeterminate. That's why under the zero exponent rule, any number, positive number raised to zero power should be equal to 1. With the given condition, a should not be equal to 0. The meaning of this, any number, I think whether it is positive or negative, okay, should be equal to 1. Okay, that's it. Just don't forget that one. The example of this is something like, if we place it here, 2 to the 0 power, and they should be equal to 1. So how do we know it was 1? Actually, we can verify this one by using the calculator, but we could prove it mathematically. 2, the base, y to the x, the power is 0, 0, and the answer should be 1. And the answer is 1. Right? 2 to the 0 power is 1. So the meaning of this, any number, whether plus or minus, raised to 0 power will be equal to 1. Supposing we try negative 2, will it be equal to 1? Will it be equal to 1? You just display 2 here, put the sign negative, raise that to 0 power, y to the x, 0 equals, it's still 1. So under the zero exponent rule, this is either plus or minus. Okay? Either a plus or minus a raised to 0 power should be equal to 1. But it should not be a will be equal to 0. Okay? Because that's indeterminate. We could not determine that one. Okay, under the power rules, this is being actually live feed on the short videos, the power rules, that is the quantity a raised to m, raise that again to the n power. If we try to simplify this one, it should be same base, okay, right? And the exponent will be the product, okay? Under the product rule here, we add the sum, but in here, okay, we are given a base raised to certain exponent, then raise that again to another exponent. The resulting simplification should be same base, and the resulting exponent should be the product of the exponent. An illustration for this, it's an easy illustration. Example. Okay. Supposing we put 2 cube. Okay. That's an exponential term, right? Raise that again to the second power. If we try to follow this, according to this, it should be that base, which is 2, and the resulting exponent should be the product of 3 times 2. So this is 3 times 2. This is 3 times 2. It is not 3 plus 2. Because according to the product rule here, it should be a plus n. But this is different, right? We are given an exponent, or term raised to an exponent, then raise that again to another exponent. So the resulting exponent should be the product. So this will become 2 raised to, what is 3 times 2? It is 6. And what is 2 to the 6th power? I think this is 64. Right? Because 2 to the 5th power is actually 32. To the 6th power, that will be 64. Okay? And we could check it. If we do not want to follow this rule here, just take the simplification of 2 cube first. What is 2 cube? It is 8. Right? I don't want to follow this. Quantity square. What is 8 square? It is equal to 64. So 64 is equal to 64 without using the rule. But if we try to use the rule that is an a raised to m, raise that again to another power n, the simplification should be a raised to the product mn. As simple as that one. Okay? Concentrate on this one. Okay, I think they are giving these problems on the SAT and the CET exams. Okay, number 2. The product AB. We got two V's. That is A and B. We are taking the product. This is under one quantity. Raised to the m power. If we try to take the simplification of this, it should be the first base raised to m multiplied by b raised to m. The operation inside is multiplication, right? So we just segregate it. So it will be the first base raised to m times the second base raised to m, because the exponent for both are actually the same. Oh, an example of this one, so we could visualize it. Okay, the product 2 times 3 raised to the third power. Okay, according to this rule here, it should be the first base raised to the third power multiplied by the second base raised to the third power. And if we try to take the simplification of this, what will come up? I will check the camera. 2 cube is 8, right? 3 cube is 27. And what will be the product? 56, 16, that is 216. Okay, we could check it. What is 2 times 3? Without using the rule, it is 6, right? To the third power. So this should become 36. 6 times 6 is 36. There's another 6 over here. So if we try to multiply this one, 6 times 6 will be 36. Okay. 3 times 6 will be 18 plus 3, that will be 216. So the result is the same by using the rule, or if you do not want to use the rule, they are the same. Okay, but I am emphasizing here that under power rules number 2, the product of 2 bases AB raised to m should be equal to, if we try to take the simplification of this, it should be the first base raised to m times the second base raised to m. The operation is multiplication. As simple as that one. Third one. The third one will be the ratio a over b raised to m. If we try to take the simplification of this, different bases, we are dividing it, and they are both raised to same power. The simplification should be the numerator raised to m all over the denominator raised to m. Okay, we just segregate the power m by placing it on both the numerator and denominator. But with the given condition, b should not be equal to 0. Because if b is equal to 0, a number divided by 0 will be indeterminate. We do not know what will be the value. That's why under power rules number 3, b should not be equal to 0, meaning the ratio a over b raised to a power m should be equal to e to the m all over b to the m with the given condition b equal to 0. Okay, we could give an illustration about on this one. Example, a 2 over 3 square. If we try to follow the rule, it should be 2 square. Okay, the base of the numerator raised to that same power all over the denominator raised to that same power. What is 4 square? Or 2 square, which is 4. What is 3 square? It is 9. So the answer is actually 4 over 9. And if you don't want to follow the rule, I don't think we could present another solution. You just square 2/3, right? 2/3 square immediately without using the rule. 2 square is 4, 3 square is 9, so 4 over 9 is same as 4 over 9. But according to the power rules, the ratio a over b raised to n should be equal to the numerator base raised to that exponent all over the base of the denominator raised to that same exponent with the given condition b should not be equal to 0. Okay? It's getting interesting. You are to use this one on the SAT and the CAT exams, so don't forget these concepts. Okay, the special rules. I think we got 4 special rules. 1 over a raised to minus n is equal to e to the n. I think we could prove this one that 1 over e to the minus n is actually e to the n. It will be something like this. If we try to simplify this one, if we try to put this one up, what will come out? It is e to the n is equal to e to the n. So it's actually true, right? So the meaning of this, 1 over a raised to minus n should be equal to e to the n. Okay? Number 2. A to the minus n, it's the reverse, right? This a to the minus n is actually, it's not under the denominator. A raised to minus n is equal to 1 over a raised to n with the given condition a equal to 0. I think this is a little bit, what they call this, it's not controversial. Because if we try to simplify this one, a to the minus n, if we try to simplify this one, this will become 1 raised to n all over e to the n, right? This is actually over 1. So if we try to cross multiply, what will come out? It will become a raised to minus n times a raised to n is equal to 1 to the n. This will become a raised to n minus n, and they should be equal to 1 to the n. It will become a raised to 0, and they should be equal to 1. So we arrive at this one. So to prove this one, we should use the zero exponent rule. This one. That is a raised to 0 power, whether plus or minus, should be equal to 1. The best illustration for this is to give an example. That is 4 raised to minus 2. If we try to follow this, it will be 1 over 4. Okay, we bring down that base raised to the exponent 2. This minus, but the simplification should be a plus, right? So this is 1 over 4 quantity squared. And what is 4 to the minus 2? If we try to bring this down, it will become 1 over 4 squared. And this should be equal to, if we try to take the simplification of this, okay, what rule we will follow? It will be this one. So we square, what you call this, we raise the numerator to this power here, and we raise the denominator to that same exponent. So it will become 1 square over 4 square. So 1 over 4 square is actually 1/16. And what is 1 square? It is 1. And what is 4 square? It is 16. So 16 is equal to 16, so it is true. Okay? So according to special rules number 2, that is a raised to minus n should be equal to 1 over a raised to n. Number 3, a raised to minus n all over b raised to minus n should be equal to b to the n all over e to the n. It's the same. Okay? If we try to bring down this one, it will become 1 over e to the n, right? And this one, if we try to bring it up, it will become b raised to m. It is this, right? So the meaning of this, e raised to minus n all over b to the minus m should be equal to, you raise this up, it will now become plus. You bring this down, it will now become plus. So e raised to minus n all over b raised to minus n should be equal to b to the m over e to the n. Right? Oh, what's next? The last one. The ratio a over b raised to minus n. Oh, I think it's the same as the third one. Because if we try to take the simplification of this, it will be e to the minus n all over b to the minus n, right? And this should be equal to, this one, if we bring it down, it will become e raised to n, right? This one, if we bring it up, it will become b raised to n, right? Same exponent, so we will take the ratio of b over a raised to n. It is this. Okay, that's it, guys. The exponential rule summary. Okay, the product rule for same base, the quotient rule for same base, the zero exponent. Okay, it's a must that we should memorize this one, that any number, whether plus or minus raised to zero power, should be equal to 1 with the given condition that number should not be equal to 0. Power rules, the quantity e to the m, raise that again. It's a double quantity. We raise it 2 times, right? E to the m raised to n should be same base to the product mn. Okay? Different base, the product ab raised to m should be e to the n times b to the m. Under the quotient, same base, this is a over b raised to m should be e to the m, b to the m. With the given condition, b should not be equal to 0. Special rules. 1 over e raised to minus n is equal to e to the n. Okay, it's just the reciprocal. And e to the minus n, okay, should be 1 over a raised to the positive n. Number 3, e to the minus n over b to the minus m, okay. You just transfer this one down, you just transfer this one up, so what will come out will be b to the m over e to the n. Last one, a over b raised to minus n, it's the same. If we try to take the simplification of this, e to the minus n over b to the minus n. So to eliminate this negative n over here, we bring it down, so it will now become plus n, right? And this one, to eliminate this negative n for the base b, we raise it up, it will now become a plus n for the b. So a over b raised to minus n should be equal to b over a raised to n. Oh, that's it, guys. So for those of you who are taking up algebra for the first time, or you've been an engineer for a long time, this is for you guys. These are the concept summary for exponential rules. If you want to subscribe to my channel is at youtube.com/@proofdavidj.de. You will get something from it because under the long video format, I am discussing concepts and I am giving example problems, okay? Good morning from Los Angeles.